We are going to do Ohm's law today, experiment number 4. The circuit that you should hook up is here. I am going to show you how to assemble it on a breadboard. In this circuit, positive of the variable supply goes to the first end of 1 kilo ohm resistor. The second end of 1 kilo ohm resistor goes to the variable power resistor. Second end of the power resistor goes to the positive of your ammeter. Negative of ammeter goes back to negative of the supply. I've connected the positive of my power supply to one end of 1 kilo ohm resistance. The second end of 1 kilo ohm resistance goes to the first end of the power resistor. This is your power resistor that is variable. The second end of the power resistor goes to the ammeter. Ammeter positive, ammeter negative goes back to the negative of the supply. These two ends sense the same voltage and resistance as these two ends. Therefore, I have connected a voltmeter across these two ends to find out the voltage across the second resistor R2. Initially, you are going to set the decayed resistance box, the power resistance, to 2000 ohms. I am going to show you how to do this. 2 in this dial, I have moved from 1 2 and 0 in here, 0 0. So 2000 ohms. I am going to set the voltage across R2 to 4 volts, 6, 8, 10 and 12. Note down the corresponding voltage across R1 and I am going to look at the current flowing in the circuit. That would be the total current. This column is the expected setting for voltage across R2. The actual measurement should be included in this column. I adjusted this power supply looking on the DMM, measuring the voltage across R2, and I have set it to 4 volts. The voltage across R1 is 2.16 volts. The current is 2 milliamperes. Voltage across R2 is seen from here. Voltage across R1 is seen from here. The expected voltage across R2 is 4 volts. Our DMM read 4.00 volts. I have noted it. Voltage across R1 shows 2.16 volts. Current from the ammeter, I have read it as 2 milliamperes. I am going to set the voltage across R2 to 6 volts and I would note the exact measured value here. I would note the voltage drop across R1, current flowing in the circuit, and I would finish this table. For this table, I have set the voltages across R2 to be these. I have noted the actual values. Voltage across R1 and the total current are noted. The next table is for the decayed resistance box setting to be 4000 ohms. 4000. With 4000 ohms power resistor value, we are going to set the voltage drops across R2 to be the same, like 0, 4, 8, 12, 16 and 20 volts, and note the voltage drop across R2, the actual values, voltage drop across R1, total current, and we'll fill up this table. Then change the decayed resistance box setting to 8000 ohms. Do the same for voltage drop across R2 to these specific values, voltage across R2 actual measured, voltage across R1 and the total current, and finish this table. Once you're done with the measurements for all the 3 tables, you can do the calculations for each of the table. Here, the expected total current is voltage across R2 over R2 by Ohm's law, and you're going to compute the values, put the values here. Next is expected voltage drop across R1 is the total current times R1, because it's a series circuit. Voltage across each resistor would be the total current times the resistance value. Percentage errors for I total and VR1 you're going to compute. Formula for percentage error calculation for IT would be expected I total from this column minus actual I total that is measured over expected I total, the absolute of it, times 100. When you take the absolute value, you wouldn't have any negative sign. Once you're done with all calculations for all the tables, you're going to plot a graph for voltage across R2 in the x-axis, total current in the y-axis. You would get 3 linear curves for each of the power resistance values. Thank you for watching. Bye.